Hi everyone. So I thought after today I would make another quite challenging discrete random variable question. It's there on the screen, so if you felt confident with the question today you can pause the video and have a go, and I'm going to go through a model solution. I've tried to encompass all of the little tricks that I can think of for a discrete random variable. But obviously that is not an exhaustible list, okay? These are just some techniques that I've seen come up in questions and I think that would be useful. So if you want to have a go, pause the video now. Right, let's get going then. So I'm going to do part A. I'm just going to move this out of the way so I've got some room. And we'll go back up to part A. So this kind of probability function is called a piecewise function. And that's because there are different ways of calculating the probability for the different discrete random variables. The top row tells me that whatever the value is that I select, I have to square it and then times it by this constant k. Whereas for these higher values, I'm going to take that value of k and divide it by x minus 2 factorial. This last line is just to say that it's impossible, or there is zero probability to achieve any other value of x. So the key piece of information here is that we know that probability always adds up to 1. So I can calculate the different probabilities, sum them, and that's going to help me to find this value of k. So I've got k plus 4 lots of k plus 9 lots of k. And then if I put 4 into here, I'm going to actually have 2 factorial as my denominator. So k over 2 plus k over 3 factorial, which is 6. Grouping all those like terms together, you should get 44 over 3 lots of k, which means that that constant is 3 over 44. I think that's quite a nice gentle opener if you had to do it. Perhaps we might want to write out the probability distribution, and that essentially means that you'd write out all of those probabilities in a little table. We're not going to do that this time, but you might be asked to do that. Yeah, and I can do the first one really easily because it's just k. So the probability I get a 1 for this discrete random variable is 3 over 44. Okay, part B. So I'm going to grab this and move it back up. Okay. Right, again, similar to what we had done today. This idea that we had, we were selecting 2 random variables. The probability doesn't change between the picks because it's independent. And after I've picked those values, I'm going to multiply them together. And we want to try and get a probability that is 16 or greater. So good technique is to think, right, I can only get the numbers 1 to 5. So 4 times by 4 will give me 16, and that's going to be the smallest combination that's going to work. I can then get a 4 and a 5, which give me 20, but I'm going to have 2 ways that I can do that. And then finally, I'm going to have a 5 and a 5 for 25. If we can now find the probability for each of those things and add them up, we should be good. So I'm going to cheat a little bit because I've worked out already just to speed up the video. But the probability of 2 5s, or actually let's do it in the order I wrote it, 2 4s is 3 over 88 squared. Then the 2 ways, so I'm going to have 2 lots of 1 88th times by 3 88ths, and then finally the 2 5s, I'm going to have 1 over 88 squared. The solution that you should get for that is a very small probability of 1 over 484. Okay. And we could write that as 3 sig fig, but we only did that today because the calculator didn't give us a nice fraction. So either will be fine for your test after Easter. Moving on to the next bit, maybe if I move this one down a bit, it should give me enough room. And then move that back up. So, given. Now, while this topic is discrete random variables, we could see a conditional probability sort of added on at the end. So we've talked about this before. We can be very routine and sort of predict the first couple of bits, and I'll do my best of like trying to show you extra little things that might be added on, but they're the parts of the question that are going to sort of turn B's into A's, A's into A stars, yeah? And spotting that this is a conditional probability is really important. So this means that we know that we've definitely got a value of 16 or more. We have just calculated that. So we've just found that the probability of getting 16 or more is this, but we now want to look at what the probability is that we got an odd. Now, actually, that's the only way that that could happen is if we times the 2 5s together. So this is going to be the probability I get an odd, which is 25, and my value of y is greater than 16. Bit of sloppy notation there, because I've got to say that, whoops, bear with me, y is equal to 15 and it's greater than 16. And we worked that out already. It's this thing here, which was a 5 and a 5. So I can slot that in, and when we do that calculation, we get 1/16. Okay. For these questions as well, if you're finding it difficult to list them, whenever it's a multiplication, you could choose to draw a sample space diagram, so like a little table, and see all of the different options. Okay, so that's a useful trick. Right, last one. Now, this is a personal favourite, and it catches a lot of students out. The key to this, if we read it carefully, is what's the probability Mr. Jordan has to choose exactly 10 random variables to get 3 2s. So the key to this is that when I get that third 2, I'm going to stop picking random variables. And that means that the last value is fixed. So out of these 10, I know that I will have picked a 2 last. The previous 9, so this is 9 chosen, and 1 chosen. The previous 9, I could get those 2s in any order. So this first bit of 9 chosen, I can use a binomial to do it, because I know I'm going to pick exactly 9, and the probability of picking a 2 is independent. So it fits our model, and I'm either getting a 2 or I'm not getting a 2. I don't really care what the other number is. Now, the probability of getting a 2 is 3 over 11, and you can check that using the piecewise function at the start. So I can put this all together now. This first bit is going to be the probability of picking exactly 2 using this binomial. So 0.2881 blah 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 blah. But then I've got to get a 2 for the 10th pick. So I'm going to have this times by the probability of getting a 2, which is 0.786236. Okay. So I hope that's useful. It's hard to find those sort of more difficult discrete random variables. It took me a bit of time to make that one up, so it worked okay. I'll post some on your Google Classroom that you can have a go at as well. All right. Yeah, as I said, anything else that I can help with, please let me know, and I'll see you after Easter. Bye.